In Space Engineers, the planets are the perfect size for flying around and exploring each and every one of them in an afternoon. Now, you might not be surprised to know that those planets and the distances between them are vastly shrunk down for playability. But what would the SE solar system look like if everything were scaled correctly? Well, my friends, today you're going to find out because we've built a scaled model of our solar system in Space Engineers, and in this episode of Space Busters, we're going to explore it. Don't worry, guys, this isn't the solar system that we're looking at. This is the default Space Engineers, you know, the star system that they give you when you just play Space Engineers. Now, I know you guys are eager to get right to it, but I need to explain 3 things before we do. We're going to go speed round, so get ready for lots of information real quick. All stuff you need to know before we go, though. First, the scaled solar system we're standing in uses a scaling factor of 1/1000th. That means that while each planet, moon, and the distance between them is proportional to the real thing, it's also 1,000 times smaller than it would be in real life. You know, just a little 1,000 times. Space Engineers wouldn't be able to handle a 1-to-1 solar system because the sizes are so big, so we have to compromise a little bit. I don't think you guys are going to be disappointed, though. Second, we're about to go on a tour starting at the Sun and going all the way to Pluto, and during that time, we're going to be doing quite a bit of flying. It's not really very easy for me to show how fast we're going because reference points in space are not amazing, so I'm just going to tell you the speed right now. So we're going to be flying at the max spectator cam speed, which is, get ready for it, 2,982,492 kilometers per hour. And for all Americans, that's 1,853,631 miles per hour. That's a bit quick. So while it might not look like it when we're actually flying, rest assured that we're going incredibly fast. And the final thing is that I've got a little fact sheet right next to me. So for each celestial body we visit, I'm going to give you guys a few interesting facts about them, just to make things a little more interesting than me just saying, this is a planet, this is a moon. I think I got some interesting stuff. So I researched all these a couple days ago, and let's just say that I had no idea planets and moons were this cool. All right, speed round over. Let's get ready to explore the solar system. Starting right off at the sun. Well, I don't really have many facts about the sun. You probably know a lot about the sun already. It's bright. It's big. It's, well, it's Mars in this case. You know, I didn't have a sun model, so we used a Mars model. So in real life, the radius of the sun is 695,510 kilometers. So if you were to draw a line from the edge to the center, that's what the radius is. It would be that large. Very, very large. So in our scaled version, the radius is 695 kilometers. Now that's about 11.5 times larger than the normal planet in Space Engineers, the normal Earth. And in fact, what I'm going to do, just to show you guys kind of, I'm going to plop a random Earth in here, so the normal sized Earth, and I'll spawn it right next to this, so you can kind of see what the difference in size is for 11 times larger. So yeah, that's what that is right there. So that's our sun in this system. That's what we're going to be using as the reference point. And every other planet, since the sun's the largest, every other planet is kind of scaled down so that the sun could fit in the game. Pretty much. Doesn't the sun look so much larger than 11 times? The reason for that is because the diameter and the radius is 11 times larger, but the actual volume and the surface area is cubed and squared respectively. They're not 1-to-1. You know, as you add more radius, it's exponentially larger in terms of surface area and volume. Okay, there's our first look at the first thing. We're now in part of our solar system. This is going to be interesting. Let's go to our first planet. We'll press K and we'll go to our GPS. I have all of our planets kind of marked down here. And we have a lot of planets and a lot of moons as well. So we're going to start with Mercury and we'll show it on the HUD and we'll start heading out there. Mercury, 57,734 kilometers. Remember, we're going our max speed here. So let's start going. 0. It's going to take a little bit. Don't worry, we're not going to fly to all of them. We're only going to fly to some of them, the ones that are close, and this is considered close. So let's keep flying. What on earth? What is this that we've come upon while flying towards Mercury? An Elon Musk mobile traveling throughout the stars. I wonder what this dude's up to. Hey dude, what are you up to?
Hello there, flying person. I am just flying away from the sun. Fancy meeting you out here.
Just flying. You've got to be headed somewhere. Did you come from the sun? You're crazy.
It's hot around the sun. That is why I am flying to Pluto, which is cold.
Pluto! You're headed to Pluto. What makes you think you could reach Pluto?
I believe that this Elon car has something called an autopilot in it, and it will take me to Pluto.
What? No way. Pluto is miles, thousands, millions of miles away from where you are right now. It's going to take you like a year to get there.
Are you pulling my leg?
Okay, fine. Let's make a deal. Let me go and show these people the grand tour of our solar system, and when I'm done, we're going to come back, And if you're past Mercury, I'll give you $100. Sound good?
I don't see any people. Okay.
All right, have a fun ride. Shoom, look at him go.
Come back, flying man I just met.
He thinks he's going to reach Mercury. It's not going to happen. Well, maybe it will. We'll see. Let's continue on our journey to Mercury. Okay, full speed again. I guess now you can see how fast we're going. Okay, we're going full speed. And I'm going to show you guys the full the full journey, I guess, this time, so you guys get an idea of how far we're going. Because it's one of the things I really want to showcase in this video is that even though everything is 1,000 times smaller than it usually is, it's still going to take forever for us to get anywhere. And I guess the whole theme of this video is that, you know, we all knew that that space was big, but we maybe didn't know how big it was. It is, whew, it's large. Space is a large boy. Let's keep going. 20,000 kilometers to go. It's nothing. We'll just make it up like it's nothing. We're almost there. Our first neighbor, or I guess the sun's neighbor is what this is. Mercury, named after a god or a goddess of either the Greeks or the Romans. I'm horrible with naming. In fact, I might... Ooh, what's that? Oh, that must be Mercury. You know what? I think this is off a little bit. Okay, so that is Mercury right there. Here's our first celestial body in the solar system, other than the sun. Mercury, it's like a gigantic rock. And it doesn't have any moons. It's just kind of sitting there. A gigantic hot rock, very close to the sun. In fact, even from here, you can already see the sun. Look how big it is over there. Could you imagine just sitting on here? Sunbathing. So one of the interesting things about Mercury is that it's incredibly small for a planet. In fact, if we don't count Pluto, because Pluto's not a planet, Mercury's the smallest planet. Mercury's only a little bit larger than our moon, which is incredible. Mercury does have an atmosphere. It's comprised of like oxygen and some sodium and hydrogen, helium and potassium, but it's really thin. You know, it's not like its next door neighbor over there. That we're gonna go visit. Mercury doesn't have any moons. It's all alone out here. Poor Mercury. In fact, not very many of our planets don't have moons. Only Mercury and Venus. All the other ones have moons. Some of them a lot of moons. But yeah, that's Mercury, our first area. And let's continue. We'll throw Venus on the map. Venus isn't as far as Mercury was. Let's take off Mercury, and we'll start headed towards Venus. See, only 50,000 kilometers instead of the 59 or so that we went last time. So let's go on our way to Venus. Named after a plant, the Venus flytrap. That's not true. That is definitely not true. Don't quote me on that one. AndrewmanGaming says Venus was named after a plant. No, it's not. The plant was named after... Well, no, that doesn't make sense either if a plant is named after a planet. Maybe because someone got the words plant and planet mixed up and didn't know. They were like, oh, it's a Venus. It's a plant. And they said that by accident and was like, hey, that's not a bad name. The Venus flytrap. Or it could be called Venus because of how deadly it is. Because this next planet that we're headed to, that will be in a jiff, is extremely deadly. In fact, one of the really cool things about Venus, and we're almost there, you can actually see it starting to glow. In fact, we can turn this off. Look at that. Look at that yellow ball of death. One of the cool things about Venus is that even though Venus is so much farther from the sun than Mercury is, Venus is incredibly hot. Venus is hotter than Mercury, which is kind of crazy. But the whole reason for that is because of the atmosphere. Venus has a super thick atmosphere, and it's, it makes things really hot down there. If you're looking for a suntan destination or like a sauna, if you're looking for a sauna and you don't know what planet to go to, Venus is definitely the one to go to. Venus is like the size of Earth, so it's like really similar. They have the same gravity, but well, it's about 800 degrees Fahrenheit on the surface of Venus because of the atmosphere. And I'm sure if you guys have heard of the greenhouse effect, that's pretty much what causes that. Venus has an atmosphere of carbon dioxide and nitrogen, and guess what? It's got clouds of sulfuric acid. Wah ha 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 ha. No, it's not a horror story. Like, Venus is actually deadly. If you were to go there, you'd die. Don't go to Venus. But you know what? Venus scared away all its moons. Doesn't have any moons. It's kind of lonely out here. So, it's lonely out in space. But you know what? No matter how deadly it is, Venus holds a special place in our hearts. Because Venus, my friends, is our closest neighbor. It's much closer than Mars is. I don't know why we want to go live on Mars when we have this beauty over here. But anyways, let's start heading to Earth. I'm sure this is what you guys have all been waiting for. By the way, I should mention these planets that we're seeing are much smaller than the Space Engineer's default planets, primarily because we had to scale them according to the Sun. So the Sun's about 11 times as large as the default planet. Venus here is about 10 times smaller. And I can show you guys what that looks like the same way I showed you guys with the Sun. We're going to make ourselves a normal Earth-like planet here. Yeah, we'll make ourselves a normal Earth-like planet, throw it right over there, and you can kind of see, you know, boom, right there. So that's what you normally spawn on in Space Engineers. That's our planet right here of Venus. Just because it had to be scaled according to the Sun. So, yeah. On such a timeless flight. Ba-da-da-bum-bum. And I think it's gonna be a long, long time till touchdown brings me round again to find. Alrighty, time to set our sights. Not on the Sun, on Earth and the Moon. Let's start heading over. And you know, I said Venus was the closest neighbor. It actually is. It's only like 40,000 kilometers away in terms of our model, which is much closer than Mars is. You'll see. Let's fly on over to Earth. So we're gonna fly to Earth, and then after we get to Earth, we might fly to Mars, and then after that we'll start teleporting, because space is kind of exponential once you get past Earth, in that every planet you go to is like so much farther than the previous one. So yeah. Alrighty, we're almost at Earth. You guys know what Earth is. You've been there before. Hopefully. Unless somehow this video got like transmitted all the way to like another planet or something, and aliens are watching this and they understand English. Or maybe it was translated. Who knows? Okay, guys, this is Earth. Terra. It's a beautiful planet, I've got to say. Of all the planets we could have like been born on, Earth is probably the nicest one. So Earth is pretty far from the Sun compared to our last two planets, but it's in what they call the Goldilocks zone, which is the zone that, you know, planets can be in and, you know, have liquid water that's on the surface and, you know, not burn people alive. So it's, you know, it's kind of in the best area that it could be. In fact, this liquid water on the surface of the planet is super rare, because usually it's too cold if you go any farther, or it's too hot when you go any closer to have this. So, you know, a lot of the other planets and moons that have water, it's in the form of ice or it's underground. But on Earth, it's above ground. We can swim in it, which is fun. Earth obviously has a really nice atmosphere as well that lets us breathe and keeps us nice and warm. The atmosphere is nitrogen and oxygen, which is good because we breathe oxygen. So here's one super interesting thing about the model here. This Earth, well, let me first explain this. So surface area, or what we call buildable area. So area on the planet that you can actually, you know, build, oops, going a little fast there. Area on the planet that you can actually build structures and stuff is exponentially proportional to the radius of a planet. So while the radius of our planet here is 1,000 times smaller than the real life Earth's radius would be, the surface area, or the buildable area on the planet, is 1,000,000 times smaller. So this planet that you're looking at right here has about as much buildable area as the island of Molokai, Hawaii. That's right, not even full Hawaii. Just a single island of Hawaii is about as much buildable area this is. And you remember when I put the Earth next to the Venus over there? Well, this Earth right here is about the same size as that Venus, so it's the same kind of correlation. Even though it doesn't really look like it when we're flying around in spectator cam, everything is super small in this model. And it has to be, again, because we're basing it all off of the Sun. Okay, let's take a look at the Moon. The Mun. Oh, interesting fact about Earth, by the way. And I want to be sure to mention this one, because it's the coolest fact of all. As of recording this video, Earth is the only planet ever known to contain life. Yeah. It's pretty important. Okay, let's go to the Moon. The Mun, as they say in Kerbal Space Program. It's really far, the Moon. It's over here, actually. I don't know why all my things are off a little bit. I think it happened when I resized the planets. Okay, the Moon, here we are. And it's interesting, actually, because the Moon is incredibly far from Earth. Not like in Space Engineers where it seems like it's really close. It's actually extremely far. And in real life, it'd be 1,000 times farther, to be fair, because of the scaling. But here's the moon, and this is the view of the Earth that we see from the moon. You know, it's obviously quite a bit farther than in the game. But the moon, it's made of cheese. Not really. Ooh, lots of craters. Actually, the moon is really interesting. So the moon has these light and dark spots. And the reason for that is, well, it's... So the light spots are like the highlands of the moon is what they're called. And the dark spots, I believe, if I remember correctly, are called like Maria or something. And what essentially it is that the dark spots are like lava. It's basalt that's been hardened over. So the moon is used to have a lot of like magma pretty much everywhere. And here's one thing I didn't know about the moon as well. The moon actually does have an atmosphere. It's very thin though, and it's made up of helium, neon, hydrogen, and argon. I had no clue that the moon had an atmosphere. So hooray for learning things. Okay, the moon. It's interesting. They say we're going back to the moon pretty soon. That's going to be fun. It's going to be really cool. All right, let's go back to Earth, and then we'll start heading towards Mars. Okay, Mars is over there. We've got Mars, Phobos, and Deimos is how they're pronounced, so I've heard. They're much farther away than Venus is from us, but I think we're going to fly here. Mars is the one where I'm contemplating teleporting because it's kind of so far, but I think we'll fly. You know what? It's fun for the novelty. We'll fly all the way there. By the way, we're flying so fast that already you can't see Earth anymore. Can you see it? No, it's gone. So that again gives you an idea of how fast we're going. And I think you can actually see Mars with the naked eye sometimes, and you can see Venus as well from Earth on like really clear nights, and when they're in like a specific position, you can see them, which is really cool. By the way, I should note that all the distances are that we're using are approximate, so they're averages. Because everything, they're not in fully circular orbits, and sometimes distances are different at certain points. So like Mars' orbit around the sun has a far point and a close point, etc., etc. Also, just for the sake of the model, everything is lined up perfectly, where in reality the planets like rarely align. That's why there's a phrase for something rare. It's when the planets align. But we've aligned them just for simplicity's sake. All right, we're almost at Mars, guys. It's a long journey, this one. A very long journey. All right, here we are on Mars. Mars is a big rock. Well, it's like sandy is what it looks like. But it's actually not sand. What it is oxidized iron dust. So Mars does have an atmosphere. It's made up of mostly carbon dioxide. At the beginning of my Space Engineers playthrough, I was talking about Mars, or at the beginning of Season 3, I was talking about Mars, and I was like, it doesn't have an atmosphere. And everyone corrected me in the comments. They were like, Mars doesn't have an atmosphere. So that's like in my brain now. It's like drilled in there that Mars has an atmosphere. So there's no actual water on the surface of Mars because it's much too cold. However, there is ice. So if you go to the poles, and I think we might be able to see it in this. I don't know though, because I'm not used to this model. Oh, I don't know. There is ice on the poles of Mars. This might be the poles. I don't know. I can't see ice from here, but the poles of Mars do have ice. And another interesting thing about Mars that I didn't know before starting this is that Mars doesn't actually have tectonic plates like Earth does. So Earth has these tectonic plates that move a lot and cause earthquakes and tsunamis. Mars doesn't have those. Mars is like one solid crust instead of a bunch of broken up crusts like Earth has. Now, Mars is not lonely. Mars actually has the company of Phobos and Deimos, how they're pronounced. I pronounced these so badly in my Let's Play thing. I was like, Phobos and Deimos. But apparently they're pronounced Phobos and Deimos correctly. Although, I'll always love saying Deimos. Sorry, that's a bit of an inside joke. Okay, so Phobos right here, Mars has moons, but it's kind of like they're not really like moons. I mean, they're moons, but they're more like rocks, pebbles, if you will. Phobos is a moon that's very small. It's just kind of a space rock. In fact, some people think that it's an asteroid that kind of just got caught by Mars and now is a Marsroid. There's Phobos. It's really small. In fact, in our model, For most of the things and moons and planets, I used actual planet models and just made them smaller. But for Phobos, I literally couldn't do that because the game doesn't support planets of that size. So I had to make like the smallest asteroid I could find. And that's Phobos. One interesting thing about Phobos, though, is that Phobos is like a cold-blooded reptile on Earth. Phobos has no way to heat itself. It pretty much solely relies on the sun's heat, which makes things interesting. So on the side of Phobos that's facing the sun, you can get a nice warm 25 Fahrenheit, which is 4 Celsius degree temperature. However, on the side that's not facing the sun, or the dark side, it gets insanely cold at negative 170 degrees Fahrenheit or negative 112 degrees Celsius. Now, that's not really a rare thing for planets to do when they don't have an atmosphere, where one side gets extremely hot and the other side gets extremely cold. The only reason it's interesting for Phobos is because the hot and the cold side are just so dang close to each other. Like, you could walk from the hot to the cold side. Well, you'd die on the cold side probably, but, you know, yeah. Okay, that's Phobos. It's, like, really close to Mars. Like, it's extremely close. Deimos is the other moon rock that Mars has. And believe it or not, I missed it. Believe it or not, it's actually smaller than Phobos. Mars just has these tiny pebbles floating around it. And we're just like, you know what? Mars seems lonely. Let's call them moons. Oh, one thing I want to mention before we head off to Jupiter, which is the next planet in our line of the solar system, is that a lot of people seem to think that Mars is like the ideal place for humanity to go right now. It's really not. So the size of Mars is just over half the size of Earth. So anyone who's going to be standing on Mars and, you know, running around is going to be facing like gravity that's like half the size. So that's probably not great for a lot of reasons. I'll let all the medical people in the comments debate that. But yeah, Mars is really not a great place to go. However, it definitely beats the sulfuric acid clouds and the lead melting weather of Venus. So yeah, that's just an interesting thing about Mars. Because before I started like doing space engineers stuff, I really thought that Mars had like the same gravity as Earth and was like the same size. Yeah, it's not. It's so much smaller. Little Mars, the little red planet that could. All right, we're done with Mars. Time to move on to the good stuff. And I'm talking about Jupiter. However, oh my. Oh man. So this is where things get a little bit interesting because up until now, is that ice? Huh. This is just a randomly generated asteroid for Deimos, by the way. But up until now, we've been traveling to each of the planets. We can no longer do that because do you see the distance there? What is that? 1.83 LS. Does anyone have any idea what LS stands for? I mean, I could tell you, but you care to venture a guess. LS is light seconds. I didn't even know the game could measure in light seconds. So it turns out in space engineers, and this is one thing I didn't know before doing this, once you get past a certain distance between two objects, the game starts counting in light seconds, which is crazy. Light seconds, my dudes. 1 light second is 299,794 kilometers. So that's pretty much just how far light travels in 1 second. So you can imagine when I was actually putting the planets in place, this caught me off guard. I was like, what's a LS? Do I really have to measure an LS now? Yeah, pretty much. But it's fine. Basically, that just means we can't fly there anymore. We could, but it would just take us a really long time. In fact, I think going there would take us about 2 more of everything we've done so far. So, yeah, we're just going to teleport. We'll teleport via our entity list showing the planets. All right, and just like that, here we are in Jupiter, our largest planet in the solar system. Jupiter is the first planet we've come across so far that's even close to the normal planet size in Space Engineers. In this model, Jupiter has a radius of about 69 kilometers, compared to the normal Space Engineers planet, which has a radius of about 60 kilometers. So Jupiter's just a tad bit larger than the normal planet in this model. In addition to being our first gigantic planet, is also a gas giant, meaning it doesn't actually have a rocky core. Well, it might have a rocky core, but it doesn't actually have a rocky surface like Earth does. If it has a rocky core, we don't know it yet because everything we try to send into Jupiter just gets pulverized. We tried it one time with a satellite. It exploded. We got some data from it, but it was pretty much a suicide mission for poor satellite. I don't remember the name of that. If any of you guys know the name of that satellite that we sent in, post that down in the comments. Jupiter is made up of mostly hydrogen and helium. That's what all that gas is mostly made of. Jupiter has this big superstorm that's right in the middle of it, and it's kind of like the defining feature of Jupiter, other than these cool traces of gas. And interestingly about this is this little storm right here, the low-res storm that we're looking at, because this is space engineers, is 2 times the size of Earth's whole planet. So you could fit 2 Earths in there. Another interesting thing that I didn't know about Jupiter before starting this is that Jupiter has auroras at its poles. And they're like intense auroras. Like there's video of them. And in fact, I'll try and put that on the screen now if I remember. There's video of those auroras and they look so cool. It looks like something out of a sci-fi movie if I'm being honest. But yeah, Jupiter has auroras. Confirmed. Jupiter is truly a cool planet. It's got like 79, I think, moons compared to R1 and compared to Mars's 2. But let's take a look at some of those moons. Starting out, we'll start with Europa, which is probably the coolest moon one of the coolest. There's some really cool moons in here, not gonna lie. So Europa has an icy surface. It's all ice pretty much. And then underneath it, it's got liquid water, which is pretty insane. In fact, before starting this, I didn't think that anything, I didn't think liquid water existed anywhere in the solar system. But here, this is just the first of many moons we're going to take a look at that have liquid water. So Europa, yeah, ice with liquid water underneath it. So I call it Hoth in my Let's Play series. It's not far off. It's pretty much Hoth. But since there is liquid water underneath, Europa just so happens to be one of the few places in the solar system where life is possible. Like, there could already be life there, and we just don't know it. Like living under the ice on in the normal water. So there could be life on Europa. It's certainly a possibility. Or there could not be, who knows. It's just really cool to think about that just this moon has the capability for life. And that's why Europa is super awesome. Let's move to Io. Is that pronounced Io? How do you pronounce that? Io? I-O. Let's go. I was flying to the moon. Burn, burn. Next to Jupiter. Now burn, burn. It was really, really far. Io, man. Okay, Io, Yo, or whatever it's called. I used a Mars model for this because I didn't have an Io planet model, but the actual moon is like super yellow. I can only describe it to you guys. You can look at pictures. Maybe I'll post pictures as well. But Io is a very hostile place, kind of like Jupiter, or kind of like Venus. It's got volcanoes everywhere. It's very, very deadly. Io is the most volcanically active place in the solar system. Just this one moon right here. It's got volcanoes all over it, and it's always exploding and causing nasty stuff to happen. And I believe the volcanoes, if I remember correctly, don't quote me on this, I believe it's because of tidal forces with Jupiter, which we'll explain later when we talk about another moon as well. But tidal forces cause volcanoes. Pretty sure. Don't quote me on that. But if you ever need to know one thing about Io, it's that it has volcanoes all over the place, and it's yellow. It's a yellow moon. Let's move on to our next one. Over in this corner, we're skipping Ganymede. We've got Callisto. We'll come back to Ganymede, don't worry. Callisto is a large large moon, quite large. It's got lots of craters everywhere. That's one of the defining features of Callisto. In fact, it's the most cratered body in the entire solar system. Just this one moon right here, orbiting Jupiter. And another thing about Callisto is that there's a possibility for liquid water underneath the icy surface of Callisto. Well, not all of Callisto is ice, but where there is ice, there's possibility for some of that H2O, according to NASA. And finally, let's move on to Ganymede. Where's Ganymede? Ganymede is the largest moon in the solar system. It's mucho bigo. Ganymede is actually larger than Mercury. So this moon here is larger than a planet, which is kind of insane. Ganymede has lots of ice on the surface of it. Although I'm not sure you can tell by this, but like the real Ganymede has lots of ice on the surface. And Ganymede, surprisingly, is the only moon with a magnetic field. All the other moons can't generate their own magnetic field, but Ganymede can, because Ganymede's a boss. It's freaking awesome. And again, with a lot of these, just like with a lot of these moons, there's a possible underground ocean underneath Ganymede, according to NASA. And Ganymede has auroras, just like Jupiter and Earth. Beautiful little displays of light. So that's Ganymede. We've got Callisto. We've got Io, and we've got Europa, the moons of Jupiter. They're really cool. It's really cool once you get to Jupiter and Saturn because their moons are so awesome. Like all of these, I think except for Io, had the possibility for like liquid water underneath the planet, underneath the moon, which is just crazy to me. Like they can all support life possibly. Callisto over there, Ganymede, and Europa. But anyways, those are the moons of Jupiter. The cool moons, might I add, of Jupiter. Let's move on to the, I would say arguably even cooler moons of Saturn. One thing I do want to highlight as well is how far these things are, by the way, how far the moons are from Jupiter. And I also ask that you remember that this is 1,000 times smaller of a distance than you would actually see. But let's zoom out a little bit. Do you see the planets currently? I mean, you see the planet obviously because it's right there, but do you see the moons? I'll tell you what, I can see 3 of the moons. I don't know where the 4th one is. You can probably see them as I'm moving right here. But as I zoom out to get a better view of everything, you might lose them. No, I can still see them. But from this perspective, you really kind of get an idea of how far everything is from each other. But it's really cool because even at this distance, you sometimes see the shadows of the moons on the planet. Which, like, there's some photos of that happening, which is really awesome. All right, but anyways, that was Jupiter. Let's move on to Saturn, which is, well, 2.16 light seconds. No big deal, as long as we can teleport. Now you guys were seeing why I was telling that Elon Musk dude that he's never going to reach Pluto, especially at the speed he's going. Saturn. All right, welcome to Saturn. Saturn looks a bit weird, but it's only because Space Engineers doesn't really support the rings, as well as it possibly could. But Saturn has rings. That's probably its most defining feature, is that it's big and it's got rings. Just kind of like Jupiter, Saturn is pretty much made of hydrogen and helium, and it doesn't have a rocky surface. It might have a rocky core, we don't know, because it's difficult to kind of see in there, but it does have a rocky, or it does not have a rocky surface like Earth does. These rings you see are actually made of rock and ice that were caused by things kind of exploding in its atmosphere. So like if you can picture like moons, asteroids, comets kind of coming in here and breaking apart, and then what happens is the pieces that break apart start breaking each other apart as well, and keep doing that pretty much as they orbit around here until they form like a fine layer of rock and ice that forms this nice beautiful ring. Saturn isn't the only planet that has rings. In fact, some moons even have rings, which is like really surprising to me. But yeah, some other planets also have rings like this, though not nearly as defined. Now we have the privilege of knowing quite a bit about Saturn and its moons, because we did have a probe called Cassini actually go and orbit Saturn like 294 times or something. So we got a lot of really good pictures of the moons and the planet itself. In fact, there's even a really good picture of Cassini, the probe that went there, taking a picture of Earth. Where's the sun? Where's the sun? Oh, the sun's over there. Okay, so Earth's over there. So yeah, the probe was like over here, and it took a picture that way and captured Earth. You can actually see the light of Earth. And that's like, it's a really humbling picture to look at, and I'll put it on the screen as well, because it shows how small we are, how much of like a little dot Earth is in the black expanse of space. It's insane. It's probably one of my favorite pictures out there that Cassini took. But Cassini has lots to offer in the way of pictures from its orbits. Saturn has a bunch of moons. Let's take a look at some of them, like Titan, probably the one you guys are the most familiar with. Other than Europa from Jupiter. But Titan is a really special planet. Titan actually has a nitrogen atmosphere, which is very similar to what Earth has. Earth also has the nitrogen atmosphere, but it's the only moon with a substantial atmosphere around it. So our moon has an atmosphere, and a lot of moons have atmospheres, but not like substantial ones like Titan does. In fact, Titan has such an atmosphere that it's said that you could take off your spacesuit and walk around on Titan, provided that you had like an oxygen mask to breathe and a heavy coat. Basically something to keep the cold out. But Titan is really cool in that regard. Titan is also the only place in the solar system other than Earth where you're going to find flowing rivers of liquid. Of course, the liquid's not water. It's hydrocarbons like methane, but it's pretty awesome. Titan has oceans and lakes and rivers of methane. It's also said that Titan might have some water underneath some ice. It's so cold that any water on the surface would already be ice, but there might be some water underneath that ice as well. Of all the places that we could look for life, Titan might be a place that life could be sustained, just because of that atmosphere. It helps keep out the radiation and such, and keep the heat in. Well, it's not very hot on Titan. It's still kind of freezing, but still, you get the idea. Titan's a cool place. Aha, here we're coming up on one of my favorite moons here. We have, how do you pronounce this? Enceladus. Enceladus. I think that's how you pronounce it. Enceladus. Enceladus is essentially just ice as well, just kind of like Europa. It's full of ice, and underneath it there's liquid water. And there's pretty much confirmed liquid water because it actually comes spurting out the planet. Enceladus has these gigantic geysers that shoot out water at 800 miles per hour into space. And some of that actually forms a ring around the planet that I don't, you couldn't see from here, I don't think. Or maybe you can. Is that the ring that they're trying to show? But I was saying that Saturn wasn't the only thing that has a ring, and Enceladus also has a ring around it because of those geysers. So the geysers come out of the ground at 800 miles per hour, and some of it forms a ring around the planet, and other of it actually comes back and lands on the planet as snow, or falling ice, I guess. Very fine falling ice. So that's pretty much what makes Enceladus really cool. So far, the two moons of Saturn that we've looked at are freaking awesome. We have one that shoots geysers out, pretty much proving that it has liquid water underneath. And then we have one that can pretty much possibly support some sort of life just because of its atmosphere. Let's move on to Mimas. Is it Mimas? Mimas. It's Mimas, not Mimas. So Mimas over here is Saturn's closest moon. It's pretty small, and it's pretty much frozen solid, which is interesting. It actually presents a paradox that I read about when researching into all of this. So Mimas is a lot closer to Saturn than Enceladus is over there. Therefore, Mimas actually has a crazier orbit than Enceladus does. It's more elongated. And because of that, Mimas should have stronger tidal forces acting upon it. And tidal forces are essentially when, this part of the moon is actually closer to Saturn than this part is over here. So this part gets pulled harder than this part does. And it creates like internal friction that creates heat. That's why things like Enceladus over there have well, it's one of the proposed ideas for why it has liquid water underneath, is because it's warm enough to liquidate that water, to keep that water liquid instead of frozen. However, there is evidence to prove that Mimas over here is frozen solid with no liquid water underneath it. So it presents a paradox. If there should be more friction happening here, therefore more heat, how come everything is frozen solid over here when everything over there is liquid underneath? So because of this paradox, you have something called the Mimas test. And the Mimas test is if you try to explain why there's water on Enceladus, and we know that there's water under Enceladus because, again, it comes shooting out of the planet very obviously. If you try to explain why there's water there, you also have to somehow explain why there's not water here. So it's an interesting thing that maybe if you want more information, you could look up. But yeah, cool mysteries with the moons of Saturn. We'll zoom out again like we did before so we can kind of see the distances. Well, I want to see the other one. There we go. Look at that. You can't even see them from up here, but you can see their dots or their markers. That's Titan all the way out there. Okay, this is Saturn and all of the stuff on Saturn. Now before we move on to Uranus, which is actually how it's pronounced, guys. I looked it up. Before we move on to Uranus, I do want to emphasize that if you're really interested in seeing some really cool pictures, look up the Cassini probe that flew around this thing. And in fact, actually, here's another interesting thing on a little segue. The Cassini probe, it flew around this 294 times, and when it was retired, they pretty much drove it into Saturn to destroy it. And the reason they did that is because it's very unlikely that Saturn has life, but it could be likely that Enceladus and Titan over there do have some sort of life. And they didn't want to risk the idea that the Cassini probe would crash into one of those planets and introduce like microbes to the surface of those. At least that's what I read. I think it's a really cool, it's a really considerate thing to do as far as scientific discoveries go. Could you imagine that's like the equivalent of a cop planting drugs on someone? Could you imagine a scientist going to a planet and then like depositing some bacteria and then coming back and saying, "Oh, there's bacteria. We've discovered alien life." Nah, you planted that. The planet's like, no, I ain't got that stuff. You planted that on me. Planted those bacteria on the surface. Okay, let's move on to Uranus, which is going to be our 7th planet in the solar system. We're teleporting again. Oh, you want me to tell you why we're teleporting? Like I did for the other ones? Let me turn these off. Boop. Boop. How long of a video is this going to be if I'm explaining something for every single planetary body? Oh, I should also note as well, and I don't know that I've mentioned this. Well, I did. I said that Jupiter has like 79 moons. Saturn has like 50, I think. 52 or something. But we're only displaying a couple of them. Some of the more interesting, more notable ones. Okay, so Uranus. Uranus is 4.82 light seconds away, which is about pretty much everything we've done so far. Double that, and you'll get to Uranus. That's how far that is in our model. In our model. Remember, everything is 1,000 times smaller than it is in real life. I can't even, man. Space is so big you can't even comprehend it. This is one solar system. This is one solar system in one galaxy, in one freaking whatever galaxies are clustered into, in whatever that's clustered. It's too big. It's too big, man. Space is OP. That's why we make nice little models like this anyway. Uranus. Guys, I know you guys are going to joke in the comments. That's why I'm saying Uranus. It's not pronounced Uranus. Even though it's spelled that way, it's pronounced Uranus. I don't, you know, whoever came up with the name was trolling or something, okay? Uranus is an ice giant. Before doing any of this, I thought Uranus was like super small. In fact, Uranus is super large. It's like, I think it's 10 times the size, no, 4. Google. Uranus is like 4 times the size of Earth. So you could fit like 4 Earths in the middle of Uranus if you like put them next to each other. So it's pretty large, and I didn't know that. Uranus has rings, guys. Saturn's not the only planet that has rings. Uranus does have rings, but very, very thin ones. You can't see them in here because it's space engineers. So yeah, that's pretty much all there is to Uranus. I'm sure that's not all there is, but that's all I could really find out that was interesting, and that's unfortunate. But the real reason for that is because with every other planet, like with Saturn and with Jupiter and with Mars, we've had probes go there, and we've like looked at them and stuff. We've found out what's good, you know, what's there. All that cool stuff about the moons of Saturn and Jupiter that I talked about, it's because we sent probes there and we learned about it. Cassini, freaking all that stuff. However, Uranus here is very lonely. It's only had one probe ever go by it, and that was Voyager 2. And Voyager 2 didn't even come by to visit Uranus. It passed by on its way out of the solar system. So the poor planet just hasn't been studied. It's been studied certainly from Earth, but it hasn't had something go in close and actually look at it like some of the other planets have. But anyways, let's take a look at some of the moons. I've highlighted 3 moons. We've got Miranda. Whoops, go too fast. Again, that gives you an idea of the speed we were traveling at the start, is how fast we go by these moons. But yeah, let's take a look at Miranda. Miranda is a moon. It's ice and silicate. It's pretty much what it's made of. Yeah. It's pretty much described as the weird looking moon in the solar system, and you can't really tell. Well, it looks weird from here, but you can't really tell from the model here. But Miranda is freaking. It's weird. It's got like these weird shapes on it, not like alien shapes, but like the geological features of it are interesting. It's got like wavy lines in some places, and then it's got like some super sharp cliffs in other places. In fact, there's one place in Miranda, you know, Miranda has canyons, and some of the canyons of Miranda are like 12 times the size of the Grand Canyon on Earth. So it's just a weird looking planet, a weird looking rock of ice and silicate. Let's move on to Ariel. Again, I don't have that much to talk about with these moons, not nearly as much as before. Ariel's pretty much the same. It's not as weird looking. It's smoother. But it's just like another big space rock. And in fact, I used a moon model for these two, Ariel and Titania, because I didn't have any actual model for them. But yeah. So Ariel's just another big rock of ice and silicate. And guess what Titania is? Titania is ice and silicate. They're all boring so far until we learn more about them, I should say. Until we send a probe to Uranus and actually discover it and actually take a look deeper into like what makes it, then we're not gonna have as many cool facts about these ones, unfortunately. So, without further ado, let's take a step towards Neptune. So Neptune is a little bit farther than Uranus was from Saturn at 5.42 light seconds, which means in the game, in our model, if we were to light a match here and there was a giant telescope on Neptune, it would take 5.42 seconds for the light to reach that. In the model, it would take 1,000 times that in real life. It's insane, man. It's crazy. It's crazy how big space is. Let's go to Neptune. Let's fly. Well, no, we're not flying. Are you kidding me? Okay, look at this. This is what would happen if I'm flying. I'm going full speed right now. Do you see that number changing that much? Does it look like it's changing? I'm still going. Does it look like it's changing that much? Imagine sitting through here listening to me talk. It's too much. What we do instead is we go to Alt F10, Entity List, Planets, and we teleport, my dudes. We teleport! Because ain't nobody got time for that. Ain't nobody got time for that. Ain't nobody got time for that. Oop. A little fast there. Alright, Neptune, kind of like Uranus, is another ice giant. Neptune has an atmosphere of hydrogen, helium, and methane. If you guys don't know what methane is, by the way, pretty sure it's what cows fart. Don't quote me on that. Methane. It's also the reason why when you go next to a trash dump, you see those big pipes like that kind of stick out of the ground. It's because if methane builds up, it becomes explosive. And you don't want it to build up and explode your trash. Pretty much. Yeah, so methane is in this place. So kind of just like Uranus, Neptune wasn't specifically visited for the case of studying it, but Voyager 2 flew past it on its way out of the solar system as well. By the way, the Voyagers are really cool. You can go and look up where they are. They're just kind of flying out in space as fast as they can go. But Neptune, an interesting thing about Neptune is that it was the first planet to actually be mathematically predicted before being discovered. So they didn't see Neptune, but they were like, you know, math says there should be a planet here. And there was. Neptune has a moon. It's called Triton. Neptune has more moons than Triton. I think Neptune has like 12 moons. But Triton, not Triton. I'm looking at I have a pronunciation cheat sheet because some of these are hard to pronounce. Like especially, what was the one I had trouble with? Enceladus. That was the hardest one to pronounce. But Triton here is the only moon in the solar system to orbit retrograde of the planet's rotation, which means, in other words, that the Earth rotates away, the moon orbits that way that the Earth rotates. But with Neptune here, Triton orbits the opposite way that Neptune rotates, which is interesting. That's kind of rare. And one idea for why that might be is because maybe Neptune captured it. But yeah, Triton's cool. Triton also has volcanic activity, which is always a fun thing for planets to have. Okay, Neptune is done. Let's take a look at our final set of not planets, dwarf planets, I guess. Oh, let's do the same thing. We'll do K. We'll turn off these ones and we'll turn on the other ones. So just so we can see how far it is. Pluto. Pluto's like everyone's favorite planet, man. Everyone loves it. Oh, you guys are gonna laugh at me when I pronounce the name of its moon as well. Pluto's not as far away as Neptune was from Uranus, but it's still like light seconds away. So we're teleporting. All right, here's Pluto, characterized by that red bit of surface. There are some really interesting facts about Pluto, by the way. So the atmosphere of Pluto, yeah, Pluto actually does have an atmosphere, is made up of nitrogen, methane, and carbon monoxide. You guys know carbon monoxide, the thing in cars that will kill you if you breathe in too much of it. But yeah, Pluto does have an atmosphere of very thinness. Other things about Pluto that are very interesting, and you can Google this stuff if you want to learn more about them. But Pluto has snow, but it's red. It's got red snow. The snow is methane. It snows methane on Pluto, and the snow is red, pretty much. Pluto's got cool mountains. Pluto has water ice in some areas, which is crazy. And Pluto also has a blue sky. The sky if you were standing on Pluto, the sky would be blue. How crazy is that? Something you'd never think of, probably. And then, of course, other than Pluto, we've got over here, really close actually, as moons go to dwarf planets, I guess, is, you guys are gonna laugh. It's pronounced Charon. I know, it looks like Charon, and that's how I pronounced it before, but it's actually pronounced Charon. If you Google it, it's pronounced Charon. So Charon here wants to see Pluto's manager. No, not really. Charon and Pluto have a very interesting relationship in that they are tidally locked to each other. So even like Charon is kind of orbiting around Pluto, but Pluto is rotating at the same speed that Charon is orbiting, which is really cool because that means that even though it's like another body, you know how the moon can like rise and set as the day goes, depending on where you are on the planet. Charon doesn't do that. If you're standing here and you see Charon right there, Charon will always be there because the speed at which it rotates is the same speed at which that orbits. It's really cool. Charon will never rise or set. Charon will always be there, watching, waiting. But yeah, that's the cool stuff, isn't it? Charon and Pluto, the two soulmates, I would say, because I think they're the only duo planet thing in the solar system. They kind of go together, like blah 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 dinkity dink. Does anyone didn't get that reference? I probably butchered it. I don't know the words. And it's kind of probably before some of your time. Grace is the word that you heard, that you heard. It's got something and something. Bam, bam, bam. It's the time and the place and the motion. Da, 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 da. If you guys haven't seen Grease, you have to watch Grease. Okay, there we go. That's all the planets and all the moons in our thing, in our 2-scale solar system, our 1000th scaled solar system, which is amazing. That's incredible. I know I kind of moved away from planet sizes towards the end and moved towards the facts a little bit, but I felt like the sizes don't really matter that much. Pretty much Neptune is the same size as Uranus, which is like 4 times the size of Earth. Mars is like half the size of Earth. Venus is the same size as Earth. Mercury's like a little bit smaller than Mars. Saturn and Jupiter are the real big boys at 69,000 kilometers and 58,000 kilometers in diameter. Or in radius, rather, not diameter. And then the other major takeaway is that some moons, like like Titan and Ganymede, are actually larger even than the planet Mercury, which is pretty crazy. But yeah, there we go. Do you now get the sense that space is gigantic and huge, and it would take you forever to go from point A to point B? Well, let me drop this bomb on you then. That whole distance we traveled from the Sun to Pluto, the 19 light seconds that we traveled in our model, is only about 1/26th of the way to the real life Earth. So if you wanted, if this were full 1-to-1 scale and the Sun were there, we would have to travel this 26 times that way behind us to get to Earth. Let that sink in for a second. That's how large. And Earth wasn't even, we flew to Earth. Do you remember the days when we were flying to planets before we were teleporting? We flew to Earth without a problem. Now just imagine doing this 26 times and imagine how close Earth actually is to the Sun compared to something like Jupiter or Neptune. It's insane, guys. It's insane. It's absolutely insane. And if this isn't enough for you guys, by the way, there is actually theorized to be a planet X, if you will, a 9th planet, or if we're counting Pluto, a 10th celestial planetary body called Planet X that is, well, if Pluto is almost 6 billion kilometers away from the Sun in real life, not in the model. In the model, it's only about 6 million kilometers away. But if Pluto in real life is 6 billion kilometers away from the Sun, this Planet X that's been prophesized to be out there is almost 90 billion kilometers away from the Sun. That's like 13 times farther than Pluto. So do this distance 13 times and you'll get to where our model Planet X would be. But the interesting thing about Planet X, and I don't know how true this is, it's just kind of something I read recently, is that some scientists believe that Planet X might be a black hole. I don't know how much truth there is to that. It's just something I read, and you should probably do some research if you're interested in that. But could you imagine that? A little black hole orbiting our solar system, orbiting our little sun. It's pretty amazing. All right, it's probably about time to go check in on that car to see if I owe that guy $100 or not. Let's go check in on him. Let's fly all the way back there. No, I'm just kidding. We're not going to fly. It's going to take way too long. It's too far. Oh, hi, person. Hi, Elon Musk. Oh my God, look at it. That's Mercury. That's the Sun. So in the time I've been recording, which is about 50 minutes, I don't know how long the video will be, probably a lot less. But in the time I've been recording, this thing has traveled only about like 6,000 kilometers at the speed it's going. How interesting is that? And it's actually weird. I did see it. I wonder if it got caught in the gravity of something. Because I did see it gaining speed and losing speed earlier. It was losing like oh, it's still losing a little bit of speed. So I don't know where that speed's being lost. Probably something to do with those wheels. But yeah, it's only traveled 6,000 kilometers at that speed. That insane speed. It's not even out of the normal solar system yet. Oh my god. Okay, I think that's a really good place to end this episode. And I think that proves the point perfectly of how big space is. That if he's going this fast, he's only this far. He's not even close to Mercury. How the heck is he going to get to Pluto? Right? It proves my point perfectly, so it's a great place to end this. If you guys have any questions or comments or concerns, please post those down in the comments. There were a lot of facts said in this video, and all these facts were just researched by me and written down somewhere. So if I got anything wrong, which is entirely possible I did, please post those down in the comments, and I'll address them in like an updated comment with corrections or something. If you guys have any interesting facts of your own to add, please also put those in the comments, because there's a lot of interesting things about space, and I'm sure a lot of you know a lot of cool stuff that I don't know quite yet. But yeah, if you liked the video, please hit the like button, put your comments, suggestions, and anything down in the comments section below, and I will see you guys in the next episode of Space Busters.